Alright, for graphing systems of equations, we are doing the independent practice on page 289. It says to solve each linear system by graphing, check your answers. We have the equation y equals -1 and y equals 2x minus 7. First thing you have to do when graphing equations is to make sure they are in slope-intercept form. For y equals -1, we're going to come to our y-axis and we're going to go down to -1 and plot a point. Because I do not have an x or a slope, that means that this is going to be a horizontal line that passes through the point 0, -1, because for every point on this line, your y is going to be -1. This equation for this graph is y equals -1. For the second equation, y equals 2x minus 7, we started our y-axis with our y-intercept, and we're going to go down to -7. Our slope is 2, so we're going to go up 2. And when we have a whole number, remember your numerator tells you where you're going up and down, denominator tells you where you're moving to the left or the right. When I go up 2, my denominator is 1. Anytime I have a whole number, your denominator, or where you're moving to the right, is going to be 1. So our graph crosses at 3, -1. It says to check your answer. How can we check our answer? Well, we do that by plugging in 3, -1 in for the x and the y. My y is -1, so for y equals -1, I put -1 equals -1, which is true. And then for y equals 2x minus 7, that is -1 equals 2 times 3 minus 7. 2 times 3 is 6, and 6 minus 7 is -1. Number 2, these equations are not in slope-intercept form, so I need to isolate my y variable. To do that, I have to get rid of this x. To get rid of x, I have to subtract x. That leaves me with -y. I have to bring this negative sign down. I cannot combine 6 and -x, so I'm just going to write them beside each other. I have to get y completely by itself, so I'm going to divide by -1 on both sides, and that gives me y equals x minus 6. When I graph this, I start at my y-intercept, the number that's by itself. I'm going to go down to -6. My slope is the number that's with my x, that is 1, so I'm going up 1 to the right 1, up 1 to the right 1, however many times you need to do that. And for 2x equals 12 plus 2y, I have to get y by itself. Y does not necessarily have to be on the left side, so since it's already on the right side, I'm going to subtract 12. We're going to work this a little bit backwards. So that gives me 2x minus 12 equals 2y. The y is still not alone, so I'm going to divide by 2 on both sides. 2 divided by 2 is 1, that leaves me with x. 12 divided by 2 is 6. So my equation is x minus 6 equals y. I'm going to go down to -6 on the y-axis. My slope is 1. And when I graph this, I see that my answer is infinitely many solutions, which means that no matter which point on the graph I plug in, it will be a true solution for both equations. All right, number 3. Again, the first thing I do is make sure that my equations are in slope-intercept form. They are not. So I have 1/2 x minus y equals 4. I need to subtract 1/2 x from both sides so that I can get y by itself. I still have this negative sign that I have to keep with my y. I cannot combine what's on the right side, so I just write them beside each other. To get rid of -1, I'm going to multiply, or you can divide by -1 on both sides. You're purpose is just making sure you get this y to be alone. That gives me a positive 1/2 x minus 4. To graph this, we start at the -4 and put our point on the y-axis. My slope is 1/2, so my numerator tells me where I'm going up. My denominator tells me where I'm going to the right. I'm going up 1, to the right 2. And for 2y equals x plus 6, I have to divide by 2 on both sides. 1 divided by 2 is going to be 1/2. 6 divided by 2 is 3. You always start at your y-intercept, so I'm going up to 3 on the y-axis. Now I use my slope. I'm going up 1, to the right 2. My numerator is 1, that tells me where I'm going up. My denominator is 2, which tells me where I'm moving to the right. And because these graphs are parallel lines, they will never cross, so there's no solution for this system. For number 4, y equals 4x minus 3 is already in slope-intercept form, so I'm going down to the -3 and putting a point. And I'm going to go up 4. Since it's a whole number, I go to the right 1. Up 4, to the right 1. And this is my graph. For the next equation, I'm not in slope-intercept form, so I have to get y by itself. I'm going to add 3x to both sides so that this -3x cancels out and leaves me with 2y. I cannot combine -4 plus 3x, so I'm just going to write them right beside each other. I have to get rid of this 2 by doing the inverse operation, which means I'm going to divide by 2 on both sides. Y equals 3/2 x minus 2. It won't divide into a whole number, write it as a fraction. But if it will divide into a whole number, then write your whole number. So, my y-intercept is -2, and my slope is up 3, 1, 2, 3 to the right 2, up 3 to the right 2. This is my graph for that problem. And I have one solution. The solution is right here where these two graphs cross. The cross does not happen right on the cross here, so we're going to have to get as close as we can, and then we'll have to check it to make sure that we're correct. This is almost halfway, but not quite. So I'd say that's about 2/5. And going down, we cross right past the 1, so that's about at -7/5. Let's plug these numbers in and see if we get true statements. We have, for this equation, 2 times y, -7/5, minus 3 times 2/5 equals -4. 2 times -7/5 is -14/5. 3 times 2/5 is -6/5. When I add these together, we're going to do the additive inverse. That gives me -20/5. And when I simplify that, I get -4 equals -4, which is true. That is a solution for our second equation. So let's try that with our first equation. We have -7/5 equals 4 times 2/5 minus 3. That gives me -7/5 equals 8/5 minus 3. To subtract, we have to have the same denominator. So to give 3 the same denominator of 5, we're going to multiply that by 5 on top and bottom. 8 minus 15 is -7. That is a true statement. So our solution is 2/5, -7/5. And our last problem. 2 racers Our two skaters are racing toward the finish line of a race. The first skater has a 40-meter lead and is traveling at a rate of 12 meters per second. The second skater is traveling at a rate of 4 meters per second. How long will it take for the second skater to pass the first skater? So our first skater has a 40-meter lead, so that's their starting point, and they're traveling at a rate of 12 meters per second, so that is 12x. To graph that, we go almost to the 50, and when I have an equation that has a table that's not going by ones, I like to plug in a number just to see 5, for example, where that's going to cross on the y-axis to make sure I'm graphing this correctly. We know that 12 times 5 is 60, and 60 plus 40 is 100, so we have the point 5, 100 for our first equation. And that'll give me a pretty good graph. As long as I have 2 points, I can graph. The second skater is traveling at a rate of 14 meters per second, so y equals 14x. Again, we want to plug in a number, so we can plug in 20. And we'll get y equals 280. So we're starting at the origin, and we're going up to 280. And that is actually where this graph just so happens to cross. It will be about 20 seconds when the second skater passes the first skater. If you have any questions about graphing, make sure you write them down and see me in class, and we will begin grouping next week.